Hello students, welcome to your Algebra 1 review video. In this video we're going to take a brief look back at everything that we've done so far this year in Algebra 1, starting way back in chapter 1 from September. Seems like a really long time ago, but yeah, we're just going to, like I say, do a brief overview of all the chapters that we've done, all the concepts that we've covered. And hopefully this will refresh your memory on some things. Hopefully this will, just give you a little insight into what might be fair game for our final quiz and inform your studying or your preparation for that. So if we start all the way back with chapter 1 from the very beginning of this class, we spent a lot of time on what we called the foundations of algebra. Okay, so these are things that we covered previously in middle school or in some other class, but we talked about even as far back as basic as adding, subtracting negative numbers, right? So we started with the idea of, even 3 plus -7, or 4 minus -2, or -3 plus 1, or 2 times -7, or 4 divided by -2, right? So all of these things dealing with negative numbers, hopefully we can handle that kind of thing. We also talked about the distributive property. The distributive property obviously had a lot of applications further on, but to start with, we just did sort of the basic distributive property where we multiplied, the number in front by the 2 pieces in the parentheses, one of which was probably a variable. And we also talked in this section about equations, what an equation is, what a variable is, what it means, to get a variable by itself. We talked also about the order of operations. So hopefully we have some memory of this. PEMDAS or GERMDAS, if you prefer that. Right, so these are all the foundational things from back in chapter 1. You can go back and look through some things there if you need to. But like I said, those were sort of the building blocks of everything else that we did. Once we got the basics down, we started solving equations. Okay, we solved equations that were multi-step in the end, but we started with very basic equations like this. X plus 3 is equal to 7. Talking about undoing, right, operations, doing the opposite of an operation on both sides of an equal sign, arriving at a solution when the variable is all by itself on one side of the equal sign. Eventually we got to some more complicated equations, something like 3 parentheses, x plus 2 is equal to 2x minus 1, right? So we might have to do a distributive property first. We might have to move some variables to one side, move a number to the other side, right? So solving equations like this for x or for some variable was generally what we did in chapter 2, 1, 2, 3 step equations, both sides and so on. In this chapter, we also talked about ratios and proportions. So, that means we were solving proportions, which is basically fraction equations where we have, 2 over x plus 1 is equal to 3 over x, right? And so we cross multiplied, right? 2 times x was equal to 3 times x plus 1. And then it ends up looking like one of these equations. In the end, we distribute and we solve from there, right? So proportions was section 2.7. And that was one of the big key things that we will need moving forward into geometry class. We'll do a lot with proportions, so make sure that you go back and review that. Solving those proportions from chapter 2, section 7, page 124 in your books, if you want to look there. Once we had mastered solving equations in one variable, we moved on to inequalities, which were very similar, except that instead of an equal sign, we had an inequality symbol. So something like 2x plus 4 was less than or equal to 8, right? And we solved, again, by getting the variable by itself. In this case, we end up at x is less than or equal to 2. And then we graphed the solutions here on a number line. Sorry that is so slanted, but we graphed these on a number line. 0, 1, 2, 3, 4. With an open circle or closed circle, and then because x is less, we would go less, right, like that. So tilt your head, and that's a pretty good number line. So remember that we graphed these based on whether or not they had the equal to line, right? Open circle if they did not, closed circle if they did, and then the symbol told us then which direction are our solutions. Are they bigger? Is the number bigger than the variable, in which case the variable goes down on the number line, or is the number smaller than the variable, in which case it goes up. So the other thing that we dealt with in this chapter, chapter 3, was we solved what we called absolute value equations. So we ended up with something like this, and then we split the equation into two separate equations, one with a negative and one with a positive, right? And then we solved, so we ended up with, this was the first time we had equations that had two different solutions, in this case, -4 and +2. So you can go back and look at that. That's section 3.7, page 207. Page 207 in your books if you want to look back at that, okay? Some examples there. So we talked about set notation in chapter 3, but we didn't, I'm not going to worry too much about that for the future. It was good to get an introduction to it, but section 3.5 and 3.8 are not super important for us. But certainly solving inequalities, graphing them on a number line, and then this application of solving absolute value inequalities. Do you remember that absolute value equations were the ones that were the V's? I don't know if we ever really did graphs of those, but that's what the graphs look like. Once we dealt with equations and inequalities, we started talking about multiple variables at the same time. In chapter 4, we talked about, we started with word problems, creating graphs to relate to situations, right? So we had some examples back then of like, blowing up a balloon, right? Increasing and then taking a breath, and then increasing and taking a breath, and increasing and so on, and then it pops and it goes back down. So we drew graphs to relate to two quantities, two variables, and then we eventually got to the point where we were looking at domain and range. Okay, domain and range, remember, are the possible inputs or x values. These are inputs, also known as x values. The range is the possible outputs, which would be the y values. And then, a relation just connects domain values to range values. So we had a lot of different ways to represent relations. We talked about mapping diagrams, right, where we had these two bubbles and we were drawing arrows over, right? That would be section 4.6, page 268 in your book, somewhere in that area. We also had graphs, and then we used something called the vertical line test. Vertical line test, which helped us determine if a relation was or was not a function. Okay, so we talked yes or no, is this thing a function? And it was a function if it passed the vertical line test, meaning anytime we drew a vertical line, it only went through one point on our graph, right? If we ever had a spot where we went through two different points on the graph, something like this, then suddenly it fails the vertical line test and we say no to it being a function, okay? So that's, like I said, section 4.6, page 268. And so that was where a lot of this stuff came from. So that's chapter 4, getting eventually to functions, okay? Then we transitioned to chapter 5 and we started talking specifically about linear functions. Okay, and linear functions, linear equations, this was a chapter where we started talking about slope of a linear equation, right? So we talked a lot about slope, and slope is an extremely important concept. So please go back and look at section 5.1 if you're unsure or can't remember a lot about slope, how to find it, right? With our slope formula, where we were subtracting our two y values, We were subtracting our two x values, making a fraction out of them, rise over run sort of stuff we were talking about, right? And then from there, we talked about linear functions in different forms, right? We talked about slope-intercept form, slope-intercept form, which was y equals mx plus b. We talked about point-slope form, which was y minus a y coordinate is equal to the slope times, in parentheses, x minus an x coordinate, okay? And then we talked about standard form. Standard form was the one where we didn't involve the slope at all. It's one that we graphed using the intercepts. So you can go back and look at section 5.5 if you want to refresh your memory on that. It was like some number x plus some number y was equal to a number. So it looked something like that. And then in the next section, we talked about slopes specifically of parallel and perpendicular lines. So parallel lines, remember, have the same slope. And perpendicular lines have opposite reciprocal slopes. Reciprocal slopes. Okay, and that, remember, meant like 2/3 became -3/2, right? We flipped the fraction over, we also made it negative. So that was the main things from chapter 5. The slope is super important. That was section 5.1, and then 5.3, 4, and 5 were the slope-intercept form, point-slope form, standard form, parallel lines, perpendicular lines was section 5.6. Okay, and then there we go, section 5.8, according to my table of contents. That's where we graphed absolute value functions. That was these guys right here. So that was section 5.8. Doesn't matter, whatever. It doesn't matter, don't worry about it. Okay, so after we talked about linear functions in chapter 5, chapter 6 was all about systems of linear equations, specifically finding solutions to systems of equations. And systems of equations, you know, they look something like 3x plus 2y is equal to 4, and then x minus 4y is equal to 7. All right, so we solved these using elimination and substitution. These were our two main methods of solving these systems. They were, you know, sort of section 6.2 and 6.3. We also briefly talked about graphing, right? When we have two lines on a graph, the point where they intersect is the solution to the system, right? So if we had these two straight lines, this would be the solution. So remember our choices here where there was either one solution, no solutions, or infinite solutions if they turned out to be actually the same line. And then the other thing that we did in this chapter, chapter 6, which is not quite as crucial to remember as we move forward, but we did also graph inequalities where we ended up with pictures similar to this, but then we ended up shading in part of the graph to represent a whole quadrant of function or solutions, excuse me. So, you know, basically these symbols change to inequality symbols. Y is less than or equal to 2x plus 1, and y is greater than or equal to, let's say, negative 2x plus 4, right? So these inequalities then could be graphed onto a coordinate grid. And then remember, each one sort of had this side of the line works, this side of the line doesn't. Where they overlapped is where we shaded, okay? So that was chapter 6. again, I think elimination and substitution are really the two crucial things to keep in our minds, to remember, and are definitely fair game for our final quiz. The rest, I'm not sure about, particularly the inequalities, but we did cover those in chapter 6. Chapter 7 then was about exponents. Chapter 7 was about exponents, and this is where we really started to get a lot of rules, right? We had a lot of rules we needed to follow here. We talked about 0 as an exponent, right? X to the 0 power always being equal to 1. We talked about negative exponents in terms of, like 3 to the negative second power is really 1 over 3 to the positive second power. We take these pieces and we drop them down to the bottom of a fraction, right? We also talked about when we had x to the third multiplied by x to the fourth, what we got to do with these exponents was add them together, and we got x to the seventh, right? We talked about that also with division. We talked about if we have a power raised up to another power, so something like m squared raised to the 5th power, we would then multiply these exponents and get m to the 10th power. So we talked about all of these different rules. Also, with fractions, if we had a fraction raised up to an exponent, 2 over 3 squared, for example, that's 2 squared over 3 squared, right? So 2/3 squared is 2 squared over 3 squared. We can give the exponent to each piece of a fraction. We can give the exponent to multiple pieces of, in parentheses, multiple pieces multiplied together, but not added. That's important to remember, right? If we have x plus y squared, we don't get to just do x squared plus y squared. That's a big no. Okay, so that would be sort of in your 7-3, page 433 would talk about this, how we can give the exponent to each piece that's multiplied, but not to each piece if it's added together, okay? And then the other thing that we covered in chapter 7 was square roots, radicals, right? We talked about radicals. We talked about, the square root of x really being x to the 1/2. We talked about how fraction exponents relate to square roots. We talked in this case also about third roots, right? That would be 1 over 3, fourth roots 1 over 4, and so on and so on. We did a lot of that kind of stuff. And then we also did some stuff with exponential equations where we had something like y equals 2 to the x power. This is something that we deal with much more in later classes, so I'm not super concerned about it right now, but we did get an introduction to that exponential growth, exponential decay, and the difference between them in section 7.6 and 7.7. So that's all chapter 7 stuff, okay? Then chapter 8 was about polynomials. Chapter 8 was polynomials when we started looking at the standard form of polynomials. We started looking at how to classify polynomials, right? So that's really important. That I think is something that we sort of struggled with, the special terms we have for classifying polynomials. So that would be back in sort of the area of page 486. So if we go back and look, some at that about binomials, trinomials, third degree, cubic, quadratic, quartic, those kinds of terms, might want to go back and look at something like that, okay? Like I said, we talked about standard form of polynomials being, the degrees, meaning the exponents going from bigger to smaller. So something like this, right, where we have fourth degree, third degree, first degree, and then no 0 degree because there's no variable there. That's the standard form of a polynomial. And then we started talking about FOIL. Okay, so this was also where we talked about FOIL. We took two binomials and we multiplied them together, right, with our double distributive property or the FOIL method. X plus 2 times x minus 1, right? We multiply the first, the outside, the inside, the last, combine into a standard form type of thing, okay? We did some special cases of that where we did like, x plus 3 times x minus 3. And all of this stuff came back to haunt us then when we did factoring, right? So the first half of chapter 8 was about classifying and then multiplying these things together with the FOIL method. And then the second half of chapter 8 was about factoring them, okay? And factoring, this was sort of the realm in which we started going digital, right? We started going to our virtual kind of stuff. So all this chapter 8 stuff is still on Google Classroom. If you want to go back and use those videos as a refresher, you can do that. Factoring, we talked first and foremost about greatest common factors, right? When we factored out, let's say you had 3x squared minus 9x, right? We would factor out a 3 and factor out an x, and in this case end up with x minus 3 left in the parentheses, right? So we take what we can, what the common pieces are, pull it to the front, like undistributing it, undistributing here. So that was the first thing that we always try to do with our factoring. And then, of course, we had factoring quadratic trinomials, that were something like this, where we'd look for two numbers that multiply to make 3 and add up to make 4. That, of course, would be x plus 3 and x plus 1, because 1 times 3 is 3 and 1 plus 3 is 4. So we'd factor into these two binomials, which again is sort of the opposite of the FOIL method, right? It's opposite of the FOIL. Then, of course, if we put a number in front of the x squared, we might have to do the window method, if possible. And then that was really it for what we did with factoring. We did talk about some special cases where you had something like 9x squared minus 36 if the first and the last piece were both something squared, and there was a minus sign in between. You could do 3x plus 6 and 3x minus 6. Right? We could do that, that type of thing. We also talked about perfect square trinomials when the two factors were the same thing, and a way to do that. So go back and look at our videos there for section 8.7, or look back at those rules, page 523 was when we got into the special cases. But the real key for us moving forward is recognizing greatest common factors and doing this factoring of quadratic trinomials, possibly with the window method, okay? Once we then dealt with factoring, we used factoring as one of the ways that we solved quadratic equations. So chapter 9, we did just a few sections of solving quadratic equations. And we started with real basic ones where we had something, like this, x squared minus 4 equals 0. Remember, we had equals 0 a lot in this chapter. We would then add 4 on both sides. 4 here, x squared is equal to 4. And then when we square root, remember when we solved these quadratic equations with x squared, we very often ended up with two different answers, right? In this case, x equals 2, x equals negative 2. Positive and negative when we do the square root. Remember, our choices for solving quadratics were two solutions most of the time, maybe one solution in very specific cases, or maybe 0 solutions quite often as well, right? No solutions, something like x squared plus 25, right? You minus the 25, and then when we square rooted the negative 25 in this case, that's a no-go, right? Our calculator doesn't like that. Also, we used factoring, as I mentioned, and the zero product property to solve quadratics. So once we factored a quadratic into, let's say, x plus 7 and x plus 2, we could take each of these pieces, then x plus 7 and set it equal to 0, x plus 2 and set that equal to 0. So that was section 9.3, 9-4, to factor and solve. That also included window method a little bit. And then the last thing that we talked about in chapter 9 was section 9.6. Yeah, so just so we're clear, we only did sections 9.3, 9.4, and 9.6 in this chapter. Section 9.6 was the quadratic formula, which was sort of what we had to do when we couldn't factor the quadratic expression or equation. And we ended up with the opposite of b plus or minus the square root of, this big long formula, b squared minus 4 times a times c, all divided by 2 times a. That would tell us the two answers for x by doing one with the plus on the top and one with the minus. And then the stuff underneath the square root, remember, was called the discriminant. And we talked in another video in section 9.6 about what that can do for us, what we can find out from that. Okay, so that's chapter 9. which we just finished up recently, last week or the week before. So like I said, all this stuff is still on Google Classroom under Chapter 9. You can find all these videos about quadratic equations. And then, of course, the final thing, just sort of a quick end of the year thing that we did was rational expressions, where we had these quadratic pieces sometimes in fractions, right? We had x squared plus 5x plus 6 over x plus 3, or maybe even like 3x plus 6 or something like that, right? So remember, we talked about factoring everything first before we cancel things out. Super, super important to factor it first, because one thing that you all would be tempted to do here, I guarantee you'd be tempted to go like this. You'd be tempted, well, plus 6 and plus 6, those are gone. And then your x's are gone, and you got x squared plus 5 over 3. No, you don't. Okay, we can't cancel things that are added on to other stuff, right? So plus 6's and plus 6's cannot cancel. But what we would do here is we would factor the top into x plus 2 times x plus 3. We would factor the bottom by taking out a 3, and we get this, right? And then we get to cancel x plus 2 with x plus 2. We end up with x plus 3 over 3, and that would be our final answer, because we are not allowed to cancel the 3's, right? Because this 3 is added to the x. Again, you cannot cancel things that are added, okay? Just to reiterate that for all of you. So something from this is definitely going to show up on our final quiz, just because we didn't get really any other chance to really do a quiz on that. So there will be something like this. We may also have to multiply some of these things, right? Two rational expressions multiplied, or maybe divided, where we had to flip before we can do that, before we can cancel stuff out, right? So obviously these videos are really recent. If you have any questions about this or anything else, I really hope that you will reach out to me. Let me know, shoot me an email if there's something, you know, that you're watching this and you're thinking, Mr. Fratek, please don't put anything from that chapter on the final quiz. I want to know that. I will either reach out and try to help explain it to you, or I might oblige that request to not put it on that final quiz. And I don't know if I mentioned this before, but just another reminder that this final quiz we're going to take, as long as you take it, it will only be counted if it helps your overall grade. If it hurts your grade, I'll just erase it from the calculation, but you can't skip it, or you'll have to take a 0. So if you have questions or concerns, that's everything that we've done the whole school year in a nutshell, okay? Chapter 11, rational expressions, just the first couple sections. Chapter 9, solving quadratics, a few sections. Chapter 8 was polynomials and factoring. Chapter 7 was exponents. Chapter 6, systems of equations. Chapter 5, linear functions. Chapter 4 was relations, functions, vertical line test, domain and range. Chapter 3 was inequalities, and then that absolute value stuff. Chapter 2 was solving equations. Chapter 1 was sort of the foundational stuff, PEMDAS, order of operations, distributive property, and so on, okay? Again, if you have any questions, I know this was a really quick overview. Please reach out to me. Let me know that you need help with something or that you don't understand something. Otherwise, that's all I have for you right now. Let's finish strong, and I will talk to you all soon.